Okay, I found a new app. Hopefully it works. Okay. So here we go. We're going to try this out. We're going to see if we can do this for free, because I'm not going to complain. Hopefully we can. Alright. So, I don't know if you've gotten a text message about another event that I started. I tried to do another thing, but that didn't work either. Alright. So we're going to try something different. Alright, so I'm just going to write it out because, I don't know how to work this, and I'm just trying to do this as fast as possible so you can study for your test. So if we have the compound C, carbon chloride, right? Alright, so the first thing you're going to do before you even start is you're going to look at the groups, or whatever the columns or the periods that they're in. So you're going to look at carbon and you're going to be like, okay, what group is carbon in? Carbon is in group 14, right? And the parentheses that's under group 14 says 4. So the number of electrons that carbon's going to have is 4, okay? So that's how you got to figure that out, all right? So chlorine is in group 17, which under that, the parentheses is 7. 7 is the number of electrons chlorine has, but the thing is, the trick to the matter is, you have 4 chlorines. So you're going to have to draw 4 chlorines in your Lewis structure with 7 electrons attached to each of those chlorines. So, the next thing that you should do is you should count up the number of electrons that you need to have in your Lewis structure so you know that you either did it right or you did it wrong. So you have 7 times 4 because we have 7 electrons for 4 chlorines, which gives you 28 plus 4 because you have to add up the carbon electrons, and there's only one carbon. So you only have to add 4 once, which is 32. Alright, so you're going to end up with 32 electrons in your whole Lewis structure. Alright? So the next thing you got to do is, I can choose between colors here. So, alright. So the next thing that you got to do is you got to be like, alright, so what is going to be in the middle? Well, obviously in this case, this is easy. You're going to have carbon in the middle. Why? Because carbon's the easiest one to put in the middle because there's only one carbon. You have to have 4 chlorines attached to the element, so that would make sense to have each chlorine on each side of the carbon. Alright, so I don't know if you learned this in class, but when you draw electrons, you start on one side and you draw 1 electron. Then you go to the other side, draw another electron. Then you go to the other side and draw another. So, what I mean by that is, this is how you're going to do it. So, you're going to start with 1 electron here, 2, 3, 4, 5, 6, 7, 8. So, it is possible for an element to have 8 electrons. So as you can see, I didn't go like this. I didn't go 1, 2, 3, 4. Nope, that's wrong. That's not how you do it. You do it like this. You go 1, then you go to the top, 2, then you go to this, 3, then you go to the bottom, 4, to the side, 5, 6, 7, 8. It doesn't have to be specific. Like if you put 8 here and you put 4 here, okay, that's fine. Like it's not going to be totally specific. But you have to have 1 and 5 electrons here, 2 and 6, 3 and 7, 4 and 8. It's not that hard. You just go dot, 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 dot. You go around the element. 1 here, then you go to the top, then you go to the side, then you go to the bottom. Another to the side, another to the top, another to the side, another to the bottom. That's how it goes. Alright. So, we're just going to clear all of this. Can I make it bigger? Oh, it's as big as it can be. Alright. Well, anyways. So, when you do that, it's going to be Sorry, this takes a little while to erase because this one's not as great. But you know, I'm not complaining because this one's free, so oh well. Alright, so what you're going to do is you're going to have carbon in the middle, right? So carbon, and that has 4 electrons. So 1, 2, 3, 4, right? Alright, next up, chlorine. Let's do chlorine. Alright, so you got 4 chlorine, so you're going to go 1 on this side, 1 on this side, 1 on this side, and 1 on this side. So how many electrons does chlorine have? 7. 1, 2, 3, 4, 5. Since there's already 2 electrons here, you're going to go to the side. 6, 7. There's your, well, your red ones are 7. 7 electrons. So then you're going to do the same for these. So it's just going to end up being that. I mean, I'm just going to make it easier for you. Alright. So now as you look at an element, you have to, each element or whatever has to have an octet of 8 electrons. Okay? Does that make sense? So each element has to have an octet of 8 electrons. If an element does not have an octet of 8 electrons, if 8 electrons are not next to an element, that's a problem. That can't occur. You have to have 8 electrons attached to an element. So you can't have this. That's only 4 electrons attached to Cl, and that's only 2 electrons attached to oxygen. That's not, it can't happen. So you have to make sure that there's an octet of 8 electrons for each element, including the middle one too. And if you count it up, you have 32 electrons. Sorry that I drew all over it, but you do have 32 electrons. There's another way to write that. As you can tell, how do I clear this page? Alright, cool. So there's another way that you could write it. So you have, let me just draw it again, just fastly. There's one more down here. Alright, so these 2 electrons between, when there's 2 electrons between 2 elements, that's a bond. So you could also write that Lewis structure like this. A line is 2 dots, which is a bond, which is 2 electrons. 2 lines is a double bond, which means that you have 4 electrons. A triple bond, there's possible you can have a triple bond, which looks like this. And sometimes you will have a triple bond. I'm not entirely sure if that's on your test, but I am just winging it. You can look up practice problems on the internet. You can look up a bunch of videos. If, hopefully this helps. I hope it does. Because I'm just spitballing here. So, okay. We're going to try another element. Let's see. Another Lewis structure. Why do I keep saying element? I don't know. Alright, let's see. That was an easy one. Alright, let's do, I think CO2 is actually different. I think CO2 is different. You might not, okay. We're going to try CO2. Alright, so carbon, we already know that that's in group 14, which has 4 electrons. Oxygen is in group 16, which has 6 electrons. Okay. So you have 6, but you have 2 of them. So that's going to be 12 plus 4, which is your other electrons over here. So you're going to have 12 plus 4, 16 electrons. You're going to have 16 electrons in total, right? Alright. So we figured that out. I just need space to do it, so sorry. I had to resolve that. Alright. So what you're going to first start with is you're going to start with your C. Because obviously that's in the middle because you have to attach oxygen to either to the sides of C. Because you have two. I mean, you could start with O, but I mean, I think it would just be dumb to start with O. So you're going to have C in the middle, so that has 4 electrons. This has 6 times 2, so I'll just write that for you. So 1, 2, 3, 4. Alright. O, we're going to do O in a different color. O has 6. We're going to attach it to this side. 1, 2, 3, 4, 5, 6. And then we're going to attach, it doesn't matter, you can attach it here, you can attach it here, you can attach it here. It does not matter where you attach it. I think you're doing something that corresponds where you have to figure out if it's a certain shape, like linear or triangular. So it really wouldn't help to put it down here. I mean, like if you're trying to figure out the shape, I mean, it's pretty easy. You can just move it around. But I'll just do it here, just for the sake of it. I mean, you could put it here. It does not really matter where you put the element, just as long as you have the little structure. So I'm just going to put it here because I believe this shape is linear because obviously it's a line. Oh, that means a line. Linear is a line. But I mean, if you put it, like let's say you didn't put the O here before I actually figured it out. Let's say like you did it, whatever, but you could move whatever you did up here and you would say it's linear. But for the sake of this exercise, we're just going to put it on the side, just so it makes sense to you that it's a linear shape because it is a line. So we have O over here. So we have 1, 2, 3, 4, 5, 6. So if you have, I don't know if you saw, but if you have an electron here, you just move to the next one. So like if you have something here and you're like this 1, 2, 3, 4, you move, since there's an electron here, you move up here and just do that. I know like what I said before, like that's just to get you started. So that's really what you do. Like you just move it. Alright. Alright. So as you can tell, if you count up the number of electrons that O has, it has 6. Let's do that. 1, 2, 3, 4, 5, 6. Let's count this side. 1, 3, 4, 5, 6. Okay, so we have 6 electrons on each O. Just going to erase it just so you don't see the red lines because it's going to confuse you when I start to explain what you're going to do next. Oh shoot, that's a brown. Sorry. Alright. So, now what you have to do is, yes, each element but carbon, well no, I'm sorry. As you can tell, each element does not have an octet of 8, do they? No. This one only has 7. This one only has 6. And this one only has 7. So, what you have to do, also, not only because there's an octet, but you can't leave any electrons alone outside of it. You can't do that. So what you're going to have to do is you're going to have to take each of these electrons and you're going to have to move it to the center on either side to make another bond, which it will look like this. So I'll like highlight it for you. I'll do translucent color so you can see it. Alright, so this electron came from here. This electron